Okay, now we're going to talk about scales of measurement. Scales of measurement is another way of classifying a variable. And it's different than whether or not a variable is discrete or continuous. It doesn't further classify variables down. It's an independent way of classifying variables according to that variable's type of measurement, the way that it measures things. And it'll take a little explaining here, but first what I like to do when I think of the scales of measurement is I make a staircase like this. So scales of measurement. There's 4 scales of measurement. The first one is nominal. The second one is ordinal. The third one is interval. And the fourth one is ratio. And what you have here is the nominal is like the simplest scale of measurement. It has the least ability to measure. If we can think of something having an ability to measure, this has the least measuring capabilities in a sense. And then when you go up the staircase, the ordinal adds something that the nominal doesn't have. And then you go up again, the interval has something extra that ordinal doesn't have. And then the ratio has something that the interval doesn't have. And the ratio then is the most capable of measuring. It has in a sense, the best measuring capabilities, if you can think of it like that. Okay, so what are the differences here? The nominal scale is just different categories. That's all it is. Just different categories. Okay, so some examples here might be eye color or gender. Things like that. And so really when you observe the value of a variable, okay, it just belongs in one category or another. Either you're brown, blue, green, whatever your eye color is. And that's the simplest scale of measurement. Now, one thing these categories don't have is that there's no order to them. Eye color, you don't put eye color in, there's no natural ordering to them. Gender, male or female, you don't order those, okay? There's no order to these categories. The ordinal scale here adds order. So these are categories with an order. They have some sort of natural ordering to them. So they're categories with order. So some examples here would be like small, medium, large, king size. Small, medium, large, king size. But there's this natural ordering to them. If you asked anybody, you would start with small, then you go to medium, large, king size. Another example would be freshman, sophomore, junior, senior. So your class standing. These are categories, but you would naturally progress. You go from freshman to sophomore, junior, senior. So these categories have a natural ordering to them. So now the thing that these categories don't have is that there's no distance between the categories. And what that means is you can't subtract these. Subtraction doesn't make sense. So I couldn't take a king size, subtract a large, and get a small. Or take a senior, subtract a junior, and get a sophomore. These operations don't make any sense with these categories. Subtraction does not make sense. So that's what the interval scale adds. It adds distance. And because of that, differences make sense. So an interval scale is a numerical scale where distances make sense. And I know that this is probably a lot harder to read, and what I should do is I should zoom in on each of these and try to keep it moved in so you can see. So numerical scale where distances between variables make sense, and so you can subtract now. So in a sense it adds the ability to subtract because differences on that scale make sense. So some examples here are temperature, dates, altitude, and what I did here is I picked some interval scales that are not ratio. Okay, so these kind of seem like, why did you pick dates and altitude? Well, what I did is I wanted scales here that were just interval but not ratio. And you can subtract here. So if it was 82 degrees today and 78 degrees yesterday, then I get a difference of 4 degrees, and subtraction makes sense. Okay? And so here differences will make sense. So now, but what is this thing that the ratio scale adds that interval scale doesn't have? And the answer to that is a ratio scale adds something called an absolute zero. So let me come over here. So the ratio scale adds an absolute zero to the interval scale. So and an absolute zero is a natural zero starting point. So what I would say is a ratio scale is an interval scale with a natural zero starting point. In other words, zero was not arbitrarily chosen. It wasn't, and so for example, think of temperatures. 0 degrees Celsius is the freezing point of water. Okay, but in Fahrenheit, the freezing point of water is 32 degrees Celsius, or 32 degrees Fahrenheit. So the freezing point of water is just some other temperature. It's just a given temperature where water freezes, and that's where Celsius chose 0 degrees to be. And if you think of dates on the, we choose 0, the date 0 BC AD, that's the birth of Christ. And then after that, then we measure from that. So 1 AD, 2 AD, 3 AD, and you measure from that. And then BC are like negative numbers below a date of 0. So 0 is an arbitrarily chosen date, the birth of Christ, and we measure from that. Just like 0 degrees Celsius is a certain temperature. And altitude is another example because when you're in a plane, what's 0? 0 is sea level. So they choose sea level to be a 0 point, and then they're measuring from that. And below sea level then would be other altitudes. But there are other altitudes. Some places are below sea level, okay, and some places are above sea level, and they just chose sea level to be 0. And in a sense, those are, in a sense, arbitrarily chosen zeros, while a ratio scale, they have natural 0 starting points. So some examples here would be height, someone's weight, the time, and time as opposed to dates has a natural 0 starting point because the time it takes you to do something, okay, when you begin, that's time 0, and then you measure, from that, but that's a natural 0 starting point. Your weight, okay, 0 pounds would be a natural 0. But of course, now I'm going to weigh a certain amount, but 0 is a natural 0 starting point for that scale of how much something weighs. So these are arbitrarily chosen zero starting points, and these are natural zero starting points. So this is kind of an interval scale plus. It's an interval scale. In other words, it has distances, but then it also has the natural zero starting point. And what I'm going to show you on another video, not on this video, because I don't want to add any more to what I've already said here, is that ratios make sense. And so I'll have another video with an example that will show you if it's an interval scale, ratios don't make sense. In other words, you have to have the absolute zero before ratios will make sense. So it's kind of interesting. So these are the 4 scales of measurement. And what I found is it's kind of nice to divide this into 2 halves. You got nominal, ordinal on one side, interval and ratio on the other. And the nominal and ordinal are kind of your qualitative variables, you know, different categories, eye color, gender, small, medium, large. And it's just that ordinal would be this qualitative variable where the categories have an order to them, while these, the categories don't have an order to them. So that's a nice way of thinking about this. Nominal and ordinal are qualitative variables, and either they have an order to them or they don't. Okay? While interval and ratio are numerical variables, they're on a number scale, and the difference between these two is either they have a natural zero starting point or they don't. And then you decide which one it is based upon that. Now, there's just a couple exceptions that you want to be careful of. In a nominal variable, zip codes are numerical. So my zip code, or you know, whatever, someone's zip code, 50702. Okay, this is a number, but it's not interval or ratio, and it's not even ordinal, because these numbers, even though I could put the numbers in order or I could subtract the numbers, it doesn't mean anything. If I took one zip code and subtracted another zip code, I would get a number, but that has no meaning as for the different regions. Okay, so they're just using numbers as different names for different regions, and so those numbers don't even have an order to them. The numbers have an order, but they don't put the regions in any order. So zip codes would be an example of where you're just using numbers to identify different categories. Okay, and so, but almost always here you're going to have nominal and ordinal will be qualitative variables, while interval and ratio are numerical variables. So go ahead, take out a sheet of paper, and this is going to be your next daily activity. And these are the same variables that you decided whether or not they were qualitative or quantitative, and if they were quantitative, whether they were discrete or continuous. But now you're going to decide what the scale of measurement is. In other words, is it nominal, ordinal, interval, or ratio? So I'll let you do that. Go ahead and press pause and then classify the scales of measurement. Okay, let's look at these. Types of variables. The time it takes you to read Chapter 1 of your stats textbook. This is going to be ratio. It's a numerical scale with a natural zero starting point. So thickness of your stats textbook, again, that is going to be ratio. It's a numerical variable. It has a natural zero starting point. So you're going to find that most numerical variables are ratio. Most of them have a natural zero starting point, and you kind of have to go out of your way to pick one of those examples, like temperature or dates or altitude. Okay, so when in doubt, probably pick ratio, I would say. The topics covered in Chapter 1 of your stats textbook. This is nominal. It's now a qualitative variable, and the topics don't have any natural ordering to them. They appear in a certain order in your textbook, but if you take another textbook, they might be in some other order. There's no ordering to those topics. So the addition of your stats textbook And I would say that this is ordinal. That's what I was thinking, because the first edition, second edition, third edition, I think at the point of this recording, it's on the 6th edition, and so they're editions that have an order to them. You have this natural ordering. But if I took the 6th edition, subtracted the 4th edition, I wouldn't get the 2nd edition. That makes no sense, okay? So there's no distance on the scale. The temperature of your stats textbook in degrees Celsius, that would be interval. So there's your interval scale, and I use temperature here, where 0 degrees Celsius is not a natural 0 starting point. Now, when I say, what about degrees Kelvin? Either you know what degrees Kelvin is, or you don't know what the Kelvin scale is. And what it is Kelvin was a scientist who discovered that the temperature of an object was how fast the molecules in that object are moving. And he then recorded what the temperature would be if the molecules were stationary. And it ends up being something 273 or something like that degrees below 0. Or something on a Celsius scale. I don't know the exact what it is, but that's an absolute 0. That's the coldest something can get. Okay, so in this case, you have an absolute 0 starting point, and it would be a ratio scale for temperature. The amount of money you paid for your stats textbook, that is ratio. Numerical scale, absolute 0 starting point. I'm sorry, a natural 0 starting point. The opinion of your stats textbook on a scale of 0 to 10 was 0 being strongly dislike, 10 being strongly like. So this was my attempt to do another interval scale. And so 0 would not be a natural 0 starting point. It's just another opinion that you might have, in this case, really strongly dislike. But it could be debated. Someone might say that there's really no distance on this scale. Everybody in their own mind has an idea of what 0 to 10 would be, and they're just, so it's a very inaccurate, imprecise scale, and based on people's opinions, which actually this is about the opinion of the stats textbook. Excuse me, I'm choking. So I was attempting to make an interval scale, but it could be ordinal or something like that. But, okay, so those are the scale of measurement.